Good morning, everybody. Happy New Year. I hope you had a fantastic Christmas break. Hopefully, you got everything you asked for and you're ready to start your last semester of school. So, what I'm going to do, as you can see, Mrs. Hurt is no longer my substitute. You have Miss Roglin here with you for the next week and a half. I will be back the Tuesday after Martin Luther King Day. I have made recordings for you. For your notes, and you have lots of practice on this topic. So I've then gone ahead and looked at some worksheets and done some of the more difficult problems on those worksheets. When I come back on that Tuesday, I will be available to answer questions for you on the chain rule. And then on Wednesday, after Martin Luther King Day, will be your first quiz over the chain rule. So from now until then, all we're going to be talking about is the chain rule. So, you have done a lot of derivatives with Mrs. Hurt, and you talked about how to do the derivative of just a monomial. You've talked about how to do the derivative of a polynomial, how to do a product and quotient. So now we are going to talk about the chain rule. And the chain rule is a way to find the derivative of a composite of two functions. Now, you guys should remember what a composition is. A composition is when you take one function and insert it into another function. If you remember, when we have this notation here, this f function is getting inserted into the g function. Okay, and I don't know if you remember, we did some of these decompositions where you had to tell me which one was a small function and which one was the big function. So basically, we're going to be doing some more of that, but then doing derivatives with it. Okay, so if you remember about compositions, since this f function is being inserted into the g function, the f function is a small function and the g function is the big function. Okay, that's going to be the key to doing this. You are going to have to identify which function is a large function, which function is a small function. So take a look. My first example. You can see here I have the sign of 3x. Which function is a small one? Which function is the big one? I normally like to identify that first. Well, I believe the big function here would be sine of x. Which means then what was inserted into sine of x? That would be 3x. Okay, now I'm going to have to do derivatives, so I'm going to go ahead and do that right now. The derivative of the sine function and the derivative of 3x. Okay, so the chain function, or the chain rule says, take the derivative of the big function. Now, my derivative of the big function is cosine of x, right here. I'm going to take the derivative of the big function and I'm going to insert the small function into it. So that means if I'm finding this derivative, I have the derivative of the big function and I'm going to insert the little function into it. Then I'm going to multiply by the derivative of the little function. So it looks like that. Now, just to write this a little bit neater, my final answer then would be this. Excuse me. You must determine what the big function and the small function are and find their derivatives. So let's try again. Well, first thing I'm going to do is I'm going to rewrite this. And I'm going to make this to the 1/2 power. So what is the big function? The big function here is x to the 1/2, which means the small function is that. I'm going to need the derivative, so I might as well find them. And now we're ready to do the chain rule. So I need the derivative of the big function. And I need to insert the little function. Derivative of the big function. I need to insert the little function. Notice I insert the little function where the x is. Then I need to multiply by the derivative of the little function. If I put all of this together with that multiplication, I get this. please do not try and distribute the 2x to the third. You cannot, because that parentheses is to the 1/2 power. Okay, let's try something with an e in it. Now you'll notice there that there's a c up there. That c is just standing for a constant. So what is the big function? The big function is that. And inside the big function, we have the small function. So I'm going to go ahead and find my derivatives. And now I'm going to do the chain rule. Take the derivative of the big function and insert the little function. Then we need to multiply by the derivative of the little function. My final answer will look like that. If you're somebody that doesn't need to write out the big function and little function, then don't. Okay, but I will, at least for now. All right, next. First thing I need to show you is this derivative. Okay, and we are going to use that with this function here. So I have the big function and I have the small function. What is the big function? Well, there isn't one that's very clear to me. Okay, because if you look, this thing looks exactly like this. So there is no big function or small function. This is just the exponential function. So I don't need this determination. So if I take a look at what I have here, I just need to basically plug in this 2 everywhere I see this a. So my derivative will look like that. And if you want to put that 2x out front, you're more than welcome to. Write it like this, 2 to the x, excuse me. And that would be your final answer. Okay. Another example here. Big function, small function. Well, big function is e to the x. Small function is sine x. Find your derivatives. And let's do the chain rule. Take the derivative of the big function and insert the small function. Then multiply by the derivative of the small function. Big function, small function. Find their derivatives. And now let's do the chain rule. Derivative of the big function with the small function inside times the derivative of the small function. Now I can distribute that negative 11 to the second set of parentheses because there's no power on it. And I still have to multiply by that other set of parentheses. So this would be my final derivative. Now, I want you to notice in the next example, I basically have 2 problems written. Notice the 5th power has been moved. Okay, in the first function, the one on the left, the power is on the x, that is on the angle. In the second function, the function on the right, the power is on the trig function, it's on the cosine. So this will be done 2 different ways. They are 2 different problems. In the first one, the big function is cosine of x, and the little function is x to the 5th. Can go ahead and find my derivatives. And let's do our chain rule. Big derivative with the small function times the small derivative. That would be my final answer. Now let's look at the next one. This time my big function is x to the 5th, and the cosine function is a small function. Find your derivatives. And chain rule. We want the big function with the little function inserted into it. Notice that the x is to the fourth power. I'm inserting cosine in for x, so the fourth power is now on the cosine. Then I have to multiply it by the derivative of the little function. And we have a final answer that looks like that. They are two different problems. There is only one small change between them. All right, let's do one more here. Big function. Little function. Chain rule. Take the big derivative and insert in the little function. Then multiply by the little derivative. And there we have our answer. Okay, so this is day one on the chain rule. You must be able to determine the big function and the little function. You'll find your derivatives. And the chain rule says use the big derivative with the little function inside of it, and then multiply it by the little derivative. Your homework is this. Book pages have been posted. The key is also posted. I did want to go ahead and go through a couple of problems here that students normally ask me about when we are doing this homework. So you can pause or stop this video, go ahead and start your homework, see how you do. I'm going to do a couple of these problems here for you so you can get some more practice, I guess. But remember, this key is also posted in Google Classroom. All right, so let's look at number 5. Okay. First thing I need you to notice that yes, this is a chain rule, but it is the product rule with a chain. So here's my two factors. Those two things are being multiplied together. The second one is a composition. So we have to do a chain rule within the product rule. The first thing I'm going to do is I'm going to rewrite this to look like that. Okay, so let's do product rule here. Product rule says to do the derivative of the first. Well, the derivative of this thing right here is just 1. Derivative of first times the second. So basically this is 1 times the second function plus, now we have to do the derivative of the second function, and that's where the chain comes in. That's where the composition is. So if I take a look at this function here, the big function is going to be x to the 1/2. The little function is going to be what's inside the parentheses. Okay, so I did the first part, which is the derivative of the first times the second. Now I need to do the derivative of the second. The derivative of the second is a chain. So we take the large derivative with the small function inside of it. Then we multiply by the small derivative. Now remember what chain rule says, or I'm sorry, remember what the product rule says. The product rule says you take the derivative of the second times the first. So I got to multiply by that first x as well. Okay, so let's recap this. This is the derivative of the first times the second. This is the derivative of the second times the first. Okay, but when we did that derivative of the second, we had to do a chain in there. All right, so what's our final answer? Final answer can look a couple different ways. Okay, I can multiply the 1/2 and the 14, which makes -7, and those two x's at the end can be multiplied to make x squared. And then I have this as well. If it were up to me, I would say this is fine. When you are looking at your key, okay, the book combines those together by moving that -1/2 power to the bottom and getting like denominators. You are more than welcome to do that if you'd like, or you can leave it just like this, which is what I'm betting that you will do. All right, let's also look at this one. This is number 6. Okay. Please notice that this square root is over the whole thing. So I'm going to rewrite it first. And this is going to be the chain rule. Big function. Small function. Now let's do the chain. Big derivative with the small function times the small derivative. Okay, so now I can distribute the half to the second set of parentheses because it does not have a power on it. And I would leave it just like this. If you look at the key on Classroom, they actually move those negative powers to the bottom and do a little bit of simplifying. You do not need to go about doing that. Okay, another one I want to look at here is going to be number 8. Okay, we have a composition. The big function. Notice the power is on the angle, it's on that t, it's not on the cosine. The big function will be that. The little function is that. Now remember, pi is a constant. So when I find this derivative, it's just a constant out there. Okay, so let's do our chain here. Big derivative with the little function times the little derivative. Put it all together. And it looks like that. All right, that's all of the homework questions that I have worked out for you. Again, your key is online, so let's see how you do. You get into some trig functions down at the bottom. Hopefully you have your sheet that has your derivatives for trig functions on them. If you need help, feel free to work together, and we will see you tomorrow.